Hello students, in the previous section I have explained about mean, and there I have shown how to calculate mean by different processes, and now in this video I am going to discuss about mode. Even in class 9 you have calculated mode of raw data, but in class 10 you have to calculate mode of grouped frequency distribution. Now in class 9 you have learned that mode is the value of the observation having maximum frequency. Suppose here I have taken some values 0, 2, 5, 7, 2, 2 and 3. Here easily you can see 2 occurs maximum number of time. Since 2 occurs maximum number of time, so in this case mode is 2. In class 10 we have to find the mode of this type of frequency distribution. In case of frequency distribution table, it is not possible to look at the frequencies and determine the mode. Here we can only locate the model class. Out of these frequencies, 28 is the maximum frequency, so we can just say that 40 to 50 is the model class, but we cannot say directly what is mode. In that case we have to use one formula which is called the mode formula. To calculate mode in case of frequency distribution table, we have to use this formula where L is the lower limit of the model class. Here in this case lower limit of the model class is 40, so L will be 40 plus F1 minus F0. Here F1 is the frequency of the model class. Here frequency of the model class is 28, so 28 is F1. F0 is the frequency of the class preceding the model class. Since this is the model class, preceding the model class, this is the class 30 to 40. So 12 is F0. 28 is F1. F2 is the frequency of the class succeeding the model class. So here succeeding class is 50 to 60. So 20 is F2. And here class size is 50 minus 40, 10. So here H is 10. So using these values we have to calculate. I hope this formula is clear. In 14b, first question is class intervals are 0 to 20, 20 to 40, 40 to 60. And 60 to 80, and the corresponding frequencies are 15, 6, 18 and 10. If you see the frequencies, here maximum frequency is 18 and the class corresponding to this frequency is 40 to 60. Therefore model class is 40 to 60. So we have to write like this. Here maximum frequency is 18 and the class corresponding to this frequency is 40 to 60. So model class is 40 to 60. Here model class is 40 to 60. So lower limit of the model class is 40. So lower limit of the model class L, we have to write 40. Size of the model class H, here 60 minus 40 will be 20. So here H is 20. Frequency of the model class, here frequency of the model class is 18. So F1 we have to write 18. Here frequency of the class preceding the model class, this is the model class. So preceding the model class is this class. So here frequency is 6. So F0 will be 6. So F0 we have to write 6. Since this is the model class, so this is the succeeding class. Here frequency is 10. So F2 will be 10. So F2 will be 10 here. Now we know mode formula is, we have to write like this: mode equals to L plus F1 minus F0 to F1 minus F0 minus F2. This one we have to multiply it by H. Here L, which is the lower limit of the model class, it is 40. Already we have calculated. F1 is 18. F0 we got 6 by 2 F1. So it will be 2 into 18 minus F0 we got 6 and F2 is 10. And this one we have to multiply by H. Here H is 20. So it will be 40 plus 18 minus 6, it will be 12. 18 to the 36, and these two both are negative, so it will be added. It will be minus 16 into 20. So we can write 40 plus 12. 36 minus 16, it will give 20 into 20. This 20 and this 20 can be cancelled. So we got 40 plus 12, which is 52. Therefore required mode is, we can write here, therefore required mode is 52, and there's the required answer. Now question number 2 of 14b. Here it is given class intervals are 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35 and 35 to 40, and corresponding frequencies are 30, 45, 75, 35, 25 and 15, and we are to find the mode of the given frequency distribution. Out of these frequencies, 75 is the maximum frequency. So the class corresponding to 75, that is 20 to 25, this is the model class. Since 20 to 25, this is the model class, so lower limit of the model class, this will be 20, so we can consider L is 20. Here class size 25 minus 20 is 5, therefore height or the class size is 5. Here frequency of the model class, that is 75, so we can write F1 equals to 75. Frequency of the class preceding the model class, since this is the model class, so this is the preceding class, here frequency is 45, so F0 is 45, and since this is model class, so 25 to 30 is the succeeding class, and here frequency is 35, so F2 is 35. So in this case we got L is 20, H is 25 minus 20, that is 5, F0 is 45, F1 is 75 and F2 is 35. Now we can apply the mode formula to calculate mode. Here L is 20, which is the lower limit of the model class. Height of the class, that is 25 minus 20, it will be 5, which is the size of the model class interval. F0 is 45, which is the frequency of the class preceding the model class. F1 is 75, which is the frequency of the model class, and F2 is 35, it is the frequency of the class succeeding the model class. Now we know the mode formula is L plus F1 minus F0, 2F1 minus F0 minus F2 into H. Already we got L is 20, so we are replacing L by 20 plus F1 minus F0, F1 is 75 and F0 is 45, twice F1, F1 is 75, so it will be 2 into 75 minus F0 is 45 and F2 is 35, and height of the class is 5, so we have to write 5 here. 75 minus 45, it will give 30. 2 into 75, it will be 150. This minus 45 and minus 35, both are negative, so it will be added. And if I add these two, I am going to get minus 80 into 5. If we want, we can place one bracket here. 20 plus 30, 150 minus 80, this will be 70 into 5. 5 and 70 can be cancelled. 5, 14 is 70, so we got 14 here. So it will be 20 plus 30 by 14. 30 and 14 again can be cancelled by 2, so it will be 15 and this will be 7. So we are left with 20 plus 15 by 7. Now it can be considered as 20 by 1. If we take the LCM of 1 and 7, it will be 7. 7 divided by 1, 7. 7 into 20, 140 plus 7 divided by 7, 1. 1 into 15, it will be 15. 140 plus 15, it will be 155 by 7. And 155 if you divide by 7, it will give 22.14. Therefore, required mode is 22.14. I think question number 3 and 4 you can do it yourself. Let me show question number 5. Here it is given age in years 0 to 5, 5 to 10, 10 to 15, it is up to 30 to 35. And number of patients, it is given 6, 11, 18, 24, 17, 13 and 5. In this table, here maximum frequency is 24. Since 24 is the maximum frequency and the class corresponding to 24 is 15 to 20, so model class is 15 to 20. Therefore, lower limit of the model class, which is represented by the letter L, is 15. Here size of the model class will be 20 minus 15, which will give 5, so 8 will be 5. Here frequency of the model class, which is represented by F1, is 24. Frequency of the class preceding the model class, which is represented by F0, it will be 18. And frequency of the succeeding class, this is the model class, so this is the succeeding class. Here frequency is 17, which is represented by F2. So we got L is 15, H is 5, F0 18, F1 24 and F2 17. Now using these values we can calculate mode, as the formula of mode is L plus F1 minus F0, 2f1 minus f0 minus f2 into h. If we replace the values, L is 15 plus f1 minus f0 24 minus 18, 2f1 will be 2 into 24 minus f0 is 18, f2 is 17 into 5. Now 15 plus 24 minus 18 will give 6, 2 into 24 48 minus 18 and 17 both are negative, so it will be added, so it will be minus 35 into 5. So 15 plus 6, 48 minus 35, which will give 13 into 5. Now this cannot be cancelled, so it will be 15 plus 5 6 are 30, 30 divided by 13. Here we can consider 15 by 1, so LCM of 1 and 13 will be 13, 13 divided by 1, 13, 13 into 15, 195, plus 13 divided by 13, 1 into 30, 30. So if I add these two, 195 plus 30, it will give 225 by 13. And if I divide, it will be 17.3. Therefore, required mode is 17.3 years. I hope question number 6, you can do it yourself. Let me show question number 7. Here it is given height in centimeter, 160 to 162, 163 to 165, 166 to 168, 169 to 171 and 172 to 174, and corresponding frequencies are 15, 118, 142, 127 and 18. As you can see, this table is not continuous because in the first class interval it is 160 to 162, but in the second one it is 163 to 165. Since it is not continuous, we have to make it continuous by using the conversion factor. To calculate the conversion factor, we have to subtract the upper limit of the first class interval from the lower limit of the second class interval, that means 163 minus 162, and that one we have to divide by 2. So here conversion factor will be 163 minus 162 divided by 2. It will be 1 by 2, that means 0.5. To make this table continuous, we have to subtract conversion factor from the each lower limit like 160, 163, 166, and we are to add conversion factor to the upper limits like 162, 165, 168 and so on. The first class interval was 160 to 162. Since we have to make it continuous, we are to subtract 0.5 from the lower limit and we are to add 0.5 to the upper limit. As a result, it will become 159.5 and this upper limit becomes 162.5. Now applying this conversion factor, the first class interval will be 159.5 to 162.5, second one 162.5 to 165.5. In this way we got this table and the frequencies will remain as it is. Now if you see the frequencies, out of these frequencies, maximum frequency is 142. Since this is the maximum frequency, so the class interval corresponding to this, which is 165.5 to 168.5, this is the model class. And since this is the model class, 165.5 will be the lower class limit of the model class, which is L. 168.5 minus 165.5, this will give 3. So height of the class is 3. This is the frequency of the model class, so F1 will be 142. Frequency of the preceding class, it is 118, so F0 will be 118. And frequency of the succeeding class frequency is 127, so F2 will be 127. Mode formula is L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Here just place one bracket. So L is 165.5 plus F1 we got 142 minus F0 is 118 by 2F1, so it will be 2 into 142, F0 is minus 118 and F2 is 127 into height of the class is 3. So it will be 165.5 plus 142 minus 118, it will give 24. 2 into 142, it will be 284 minus 118 and 127. These two will be added because both of them are negative. It will give 245 into 3. Now 165.5 plus 24. 284 minus 245 is 39. Now this 3 and 39 can be cancelled. So if I cancel 3 and 39, it will be 13. So we are left with 165.5 plus 24 by 30. So it will be 165.5 plus 1.853. If we add these two, it will be 167.353. Therefore, required mode is 167.35 centimeter, which is the required mode. In question number 9, it is given that the mode of the given data is 36. We are to find the missing frequency. As you can see, class intervals are 0 to 10, 10 to 20. It is up to 60 to 70, and the corresponding frequencies are 8, 10. This value is missing 16, 12, 6, 7. In this question, mode is 36 and we are to find the missing frequency. In this question, mode is given as 36 and we are to find this missing frequency. We can consider this one to be x. From these given frequencies, we cannot say which is the highest frequency as this value is missing. But in the question it is given mode is 36 and 36 lies between 30 to 40. So model class is 30 to 40. So here we can write like this. Here mode is 36 which lies between 30 to 40. Therefore model class is 30 to 40. Now if we take 30 to 40 as the model class, this is the lower limit of the model class. So L is 30. Here class size or height of the class is 10 because 40 minus 30 is 10. This is F1 which is the frequency of the model class. So F1 will be 16. Here X is the frequency of the class preceding the model class. So F0 will be X, and frequency of the succeeding class which is represented by F2 will be 12. With these values we have to find the value of X, and here mode already it is known which is 36. Now we are going to use mode formula to calculate X. We know mode is L plus F1 minus F0 by twice F1 minus F0 minus F2 into H. Here mode is given 36, L 30 plus F1 minus F0. F1 is 16, but F0 we don't know, we have considered it to be X. Twice F1, so 2 into 16 minus F0. F0 we have considered X minus F2 is 12 into 10. So 36 minus 30. This 30, if I transfer in the other side, it will be minus 30 equals to 16 minus X. 16 to the 32 minus X minus 12 into 10. So 6 equals to 16 minus X by 32 minus 12 is 20 minus X into 10. If I cross multiply, 6 into 20 minus X equals to 16 minus X into 10. So 6 into 20, 120 minus 6X equal to 16 into 10, it will be 160 minus 10 into X, 10X. Minus 6x, this minus 10x, if I transfer in the other side, it will be plus 10x. So minus 6x plus 10x, it will be 160 minus 120. Minus 6x plus 10x, it will give 4x equals to 40. So x equal to 40 by 4 and 40 by 4 is 10. Therefore, missing frequency is 10, which is the required answer. I hope remaining sums of 14b you can do it yourself. So that's all for today. In the next video, I am going to show sums of 14c. Till then, bye bye, take care and wait for the next part.